so I want to go through this two different ways. First, I want to solve it using SOHCAHTOA, and then there's another way that I could solve it. How?
Law science.
Not yet. I mean, you could later. It's a 30, 60, 90 triangle, right? So you could use those relationships also. So I want to do both, just to show you that they both work. So let's look at SOHCAHTOA first, using our sine, cosine, tangent functions. What do we know in respect to the angle that we're given? So in other words, what function am I going to use? I'm given this angle right here. So Jake, what's true about W? What do we, it's the hypotenuse, right? And then Jack, what's the other leg that we're given?
Adjacent.
The adjacent. So if I have adjacent and hypotenuse, what trig function are we using?
Cosine.
Cosine, right? So someone write out the sentence for me using that ratio of cosine that we know. Don't all jump at once. Go ahead, Dave.
Cosine is equal to.
Cosine of what? What's our angle?
Cosine of 30.
Of 30.
Is equal to 22 over W.
Okay. So why did I want to talk about this one? Why is it different from the last one that we talked about? Go ahead, Adam.
Because it's going to be W cosine 30
Right.
equals 22, and you just divide 22 divided by cosine 30.
Tell me more about that. How is, or why is it W cosine 30? Why'd you do that?
Because you have to cross multiply. It's like having a 1 under cosine over 30.
Good. So the issue right now is the W is in the denominator, right? And you can't solve for a variable if it's in the denominator. So we have W cosine of 30 equals 22. And then Robin, how would I solve for W?
You divide
By,
22. Or no, by cosine of 30.
good. What did you guys get for that one? Wasn't it like 25 point something?
5.4.
Okay. Okay, so now let's look at this as a 30, 60, 90 triangle. So someone label my sides for me. What are the relationships that we know for 30, 60, 90 triangle? Hi, Jake.
Okay, we know that the small leg is N.
Where is this? Where does the small leg go?
Opposite of 30.
What do you mean?
I know that the small leg is N, and usually it's the one that looks the smallest, but how do we know for sure? And Adam said what?
Opposite of
It's the one right across from 30, right? Zach, what's the next one?
Look for what? That 30, 60, 90?
Yeah,
Which one's doing that already?
N, the smallest one across from
Then
30.
there's 2n, which is the hypotenuse.
Good.
Then the square root of 3.
So now how would I go about finding the hypotenuse if we were looking at it as a perfect right triangle? Or a right triangle, a special right triangle. There we go. Go ahead, Matt.
Why do you use 30 instead of 60 or 90? Because 30 is the smallest angle?
To do, what do you mean?
To figure out n.
You can't use 60 or 90 because it's not the opposite. Well, you can't just.
Are you talking about when we used cosine earlier, cosine of 30, or are you talking about right now?
I
when
don't
it-
know which side is going to be n.
It's
the
Which
one-
angle?
So 30 is our smallest angle measure, yes? I gave it to you. I gave you the angle measure 30, right? So n is the smallest of these three values, right? Because here I take n and double it, and here I take n and I multiply it by the square root of 3, right? So n is the smallest side, and that has to be across from the smallest angle. Does that make sense? Okay. And 2n, that's going to be the biggest side, and that makes sense because it's the hypotenuse, which is always the longest. So now what? How do I find n now, knowing where all of my relationships go? Go ahead, Katie.
You can set root 30 and equal to 22.
Okay. And then this is a process we went through yesterday. Eris, what's my next step to get n by itself here? And then yesterday I said that there's a situation, and what is that situation?
Can't split the thing divided by the square root.
Right, so how did we change that?
Then we do to the power 1/3.
We didn't. That would be cube rooting it. Go ahead.
When you multiply by root 3 over root 3, that's the same as 1, it's not changing it. And you can get rid of
So what's root 3 times root 3?
3.
Good, so that's how we get rid of the irrational denominator. And so this gives me n, right? If you plug that in your calculator, you get 14 point something. I don't remember exactly. And then to find the hypotenuse, you take that and multiply it by 2 and it will get you right back to 25.4.
You
So-
can't simplify this, no. For-
Good question. Why can't I simplify the 3 and the 3?
Because one of them is the square root.
Other because they're being multiplied.
Right, what'd you say?
You don't wanna change the value. Wait, no, that just came out before. Because like it's the square root of 3, not actually 3.
Right, so if you're trying to count bananas, you can't combine bananas and oranges, right? That doesn't give you a count. So you're looking at things that are similar. You can only combine or simplify values or coefficients and only combine and simplify things that are under the root. Good. Okay, this joke was my favorite because it was hilarious. It was, what was it? What makes headlines? Corduroy pillow hat.
I got you.
Isn't that funny?
Don't even know what it is.
Do you know what corduroy is?
No, it's kind of fabric. It's like got lines in it.
It's like the
Corduroy
fabric
pants.
that's got like the little, it's got
Ridges?
texture like lines.
My grandma's like,
The question is, you can find it.
And put your face on it. Like
Yeah, a little bit.
lines.
Okay, so we are moving on. Zach, what are we doing today?
Students will conduct an experiment with a pendulum that will result in a sine curve. They will predict ways to change the shape of the curve.
Thank you. So let us open our books, please, to lesson 711.
It's in the software.
Is that,
What page?
that,
Okay.
when we were teaching
Yeah.
There's a pendulum.
pendulum.
Stay.
I did. I didn't.
Okay. Oh boy, we're in the sample.
We're opening the lesson 711. Thank you. Hey, Pahina. Hey, language. What page is it, Jake?
312.
What is it?
312.
16. Whoa.
312. Okay. Jake, will you read the lesson introduction for us, please?
Yes.
Where is it?
In this chapter, you will, at the very top of the page.
Oh. In this chapter, we will learn about a new family of functions that are very useful for describing relationships that are
Cyclic.
cyclic. That is, they have repeating cycles. Like the height of the ocean, as the tides fluctuate between high and low, or the distance of a swinging pendulum from its center.
Good. Who wants to read problem number 1 with a lot of dramatic effects?
Brian.
Brian, you got this?
Yeah, hold on.
Okay.
Emergency! Nurse Nina rushes through the hospital with one hand on her clipboard and the other on a portable blood stand. The bags of blood swinging from the stand are needed in the emergency room stat for 3 patients in severe need. She is so intent on delivering the blood in time that she does not notice that one of the bags has a small hole in it and is dripping on the floor behind her. As she reaches the emergency room, she is horrified to see a small pool of blood beginning to form on the floor. Looking down the corridor from where she came, she sees the trail of blood that dripped and notices that it forms a very interesting pattern. What shape do you think the trail of blood created?
And then read what our task is.
Your task. Use the materials and instruction provided by your teacher to recreate the pattern that the nurse saw on the hallway floor behind her. Make as many observations as you can about the shape you see and how the shape relates to what was happening to the bag of blood. Be sure to keep track of all the details. Be prepared to explain your observations to the class. No, complete directions for conducting this experiment on the next page.
Thank you.
Yep.
Okay, so yesterday, me and our 4 little volunteers ran through this, so we don't have to read the directions, but if those 4 could come up, so that we could run this, it would be great. Who wants to hold first?
She's trying to
Alright.
Do you want this or no?
Do it.
Do it, you look like a doctor.
Oh, I got it, bro.
Okay, so what you need to know about this, when we had the blood drive, we asked the Red Cross if they would give us some for our experiment, so here this is.
Oh, yeah.
Just kidding.
Thanks,
Um, And this is what, in terms of the story, what's the white? It's the floor, right? And then this is the bag of blood. So, do you guys wanna do just a run through before I cut it?
Yeah.
So, Adam is gonna hold it. Make sure it's right in the middle, down a little bit, please. Down a little bit more. I don't want it to. Okay, that's good. So that's the middle, good. So, let's, can you scoot you scoot back, please.
Sure.
Oh, that's, okay. You come back. You're good.
Oh, yeah, sure.
Okay,
Roll it
so-
down to the paper.
Do a run through quick, so I'll swing and you guys go. You can go faster. Good. Okay, and then I'm gonna catch it. Okay, but make sure you hold on to it so that we don't, no, I have a bag that I'm gonna do it. Make sure you hold it tight too. Okay, so if you wanna go back, I was really nervous for this third hour, and it was awesome, but I got red all over myself, so. I'm kinda nervous, I was on the other side third hour. Will you come be my helper in case I need anything?
Sure, we can do it.
Yeah, let's
Roll
do
this
it.
way so we can like get to the end, the edge.
Okay,
Just when you.
will you hold this? Yes, will you hold this right?
That's right here, so right there.
Okay, yep.
Never mind.
Make sure you're out in the middle. And make sure it lays flat on the table too, so that we get a good.
Never mind. Do what you do.
Is that in the middle?
I didn't think about that.
Yeah, it's good.
Oh,
Come a little bit back. Okay, and you need to be right next to me so that I
Okay.
can grab that from you quick.
Which way, you're gonna be right over here?
Yeah, so come over on this side of me, but make sure you're not in this way. Are you guys nervous?
Nope.
Very.
Hi,
I'm trembling.
Alright. You guys ready?
Am I in the middle?
Just
Just
like
make sure.
not even-
No, cause I cut it already.
What actually is
Yeah, it's in the middle.
Okay, ready? Go.
Oh, ew.
Oh my god, ew.
Oh, it looks like one of those, it looks like a heart monitor.
Oh, does it, Brian? Ew.
Oh.
No, like
That was good.
Good.
Okay, let's put, if you guys wanna put this,
Good.
ooh,
We're
back
down.
up at this, on the floor back here, that'd be awesome.
Here.
Here. Let's let Adam know.
Mystery, what is that?
What's so special about this blood?
As in, yeah.
Why do they need it scanned?
Oh, it's pain.
Because there are 3 patients that are in severe
So
need.
it's like.
Yeah.
You guys can put that down.
Or something.
So what I want you to do in your teams for approximately 5 minutes is 2 things. So look at me for now. So you know these 2 things. Thanks. Thanks. Thing number 1, I want you to make as many observations as you can about the shape of this curve. Thing number 2, I want you to come up with 2 ways that we could change it. So how could we do this experiment again, but change what happens to the curve? Okay, so I'm gonna give you 4 to 5 minutes in your teams. Recorder reporters, you are new and where are you? Who are your new recorder reporters? Katie, you're 1. Brian, that's you. Eris, you're 1.
Yo.
And Nate, that's you. You should be writing for your teams and ready to share out in about 5 minutes, okay? Team on 3, 1, 2, 3.
Team! Oh.
Like how there's need to make the.
Just move fast.
This was good.
No, my job's just to write.
It's a good resource.
What do you
I
think?
guess I did, right?
It's blood.
I mean,
Don't look at me like that.
Me.
Blood.
Blood. Oh, good. Can we?
Bigger than those shrimps.
How fast the light is.
What are we trying to explain?
Blood.
Just observations about the curve. So what does the curve look like? What are similar things that you see that look like that? Yeah, so just stuff like observations that you make. Look at the lesson introduction. It talked a little bit about what this is.
Back and forth.
You can do it in circles.
How fast will that go? It's smaller and smaller because they're dull.
Blood.
Short lived for us.
It's blood.
Really,
No, it's 1.5 ounces of water and a bunch of.
Are we allowed to go walk up there?
Yeah, absolutely.
Movie I forgot, it's called Your Nut. This girl ran out there, she's like scared. And there's this wire right there, and the wire ran to her neck, and she was going like this, and the glove was orange, like. And then the stuff, and then it was red. It wasn't red, it was literally like. That's not blue.
Stable look the same. There's one we'll talk about.
So it's
how
little funky
the
donkey thing.
difference as we go into the difference of sine and cosine waves. Tangent is different from both of those, right? But sine and cosine look the same. They just are different depending on where they start on the coordinate plane. So they both look like that.
You could have changed, so
Wave it harder.
No, that was like, how did, what do you mean? Okay, so that would make it, okay, that's good. That's move the paper faster, good.
She has an equal.
Should I write that stuff down?
Eventually
What is that, what does that even say?
That's Sarah's language.
You should be a
It's not paint, it's blood.
Well, ask him, look at his red finger.
You should be a military.
Okay, are you guys good?
You're caught red-handed.
Katie. What was one, sorry, I had something in my throat, thank you. What was one observation that your team made about her?
After like the first like wave, it has like a very, has a constant like wavelength and size, like, and they have like a crest and a trough.
Right, nice, I like all that.
I remember those.
Yeah.
So, one vocabulary word I want to put to that is that it's cyclic, right? It repeats the same pattern. Does that make sense? Okay, and that we talked about that. That was in the introduction, right? That word, cyclic.
How do you say that? How do you spell it?
Cyclic, C-Y-C-L-I-C.
It's in the.
T-L-I.
Jack made a very interesting observation. What, in math, what type of curve is this? Sine or cosine. This is what the graphs of sine and cosine functions look like. So I'm going to be referencing this shape a lot throughout this chapter because this is what the graphs are going to look like that we're going to be creating for sine and cosine functions. Starting tomorrow, we're going to work with sine functions. Anybody else make observations about it? Go ahead, Evan.
As time will go on, it'll slowly get smaller and smaller and smaller.
Right. For this example, because we're in a real world, right? For a sine curve, do you think that would happen? If we were in a perfect world, it wouldn't, right? But that's a good observation that since we're doing a real life experiment, we're gonna get real life results, right? Okay, so what did you guys come up with for ways that we could change it? Nate, what's one you guys came up with?
How much or how little the bag swings.
Okay, so
Oscillates.
like that would be me changing it, right? So like pull it back farther or just pull it a little bit, right? Matt?
The speed at which your speed is moving.
Okay, so in this experiment, that would be how fast they're moving the paper, right? Alex?
If she stops as she's walking.
Okay, so that would change the whole shape of the curve, right? Good, yeah,
If the bag isn't swinging straight,
okay. So that would also make it like an imperfect situation. Go ahead.
How close the bag is to the paper.
So the length of the string, right? How far away she is from the ground. Good, so what we're gonna do now is we're gonna do this 2 more times. And I want you guys to choose which experiments you wanna try. So which one do you wanna try next? Do you wanna have them move faster? Do you wanna have them move slower? Do you wanna shorten the string? What do you wanna do next?
Make the bag go in a circle.
That's not a sine curve. Nice try.
Oh yeah! Yeah, twist the string.
What?
Twist the
But
string.
that's not a sine curve
Just do
anymore.
it. Okay, fine.
So, hold on, what are we doing? What do you guys want to do first?
Probably shorten it.
make the paper.
I still want it to be a sine curve.
Shorten the
Make them slow.
Shorten the string.
Shorten up.
We can do both. Okay, let's.
Math.
I don't have like 17 pieces of paper. I have 2 for us to do. So, who?
Just go over it.
What?
Go over it.
Let's go slow first. Is that fine? Okay, fine. When they go slow, I'm probably gonna maybe mess with the experiment a little bit because what's gonna happen to the pendulum if they're going super, super duper slow? It's gonna like stop, so I might have to step in a little bit to make it keep going.
Well, we can see like how far it like
Where is
goes
the,
until
can
it
you
dies
make
off.
sure we have the bag ready? Will you be my helper? Okay, so is
Is
it
it in the middle? Is it in the middle was the question.
Is that good?
Yep.
Okay,
You're
you guys
pulling
ready?
it.
Yeah.
I'm going at your speed. It's all up to you.
Make it flat. We're good?
So.
Okay.
Wait.
Go.
Okay. Wait.
Wait.
That looks cool.
Perfect.
David, David.
It's good. It's just shrinking. It's perfect.
Actually, it looks really cool.
Oh.
Maybe catch it or. There we go. Alright, you guys can put that one down.
There's paint on your floor.
I know. I'll get it.
It's not paint.
This whole step in it.
Oh,
It's
yeah.
blood.
Blood. Alright, then
No,
lick
no,
it
no.
up. It should be fine.
Zach, will you grab some paper towel?
Yeah, I got it.
Thank you. Guys, that one was good. So, let's
alright.
think conversely of that. What would happen if they were to go really fast?
Bigger waves.
The waves would be spread out, right?
Crest to crest is long.
Does anybody know a vocabulary word that goes with how wide things are? That's a part of it. There's another word.
Time
Press.
high.
No, that's the top.
Time high.
Think of it this way.
That's for
How many times it happens in a given
Frequency.
frequency? Good.
Yep.
Good. So, okay, so you grab another
It's
good.
not digital. It's analog. Analog.
time high. No, you're good.
I was like,
I did a wall.
should go like this and look like.
Side is that I cut.
How could it be?
You won't remember my
Yeah, I did.
That'll be awesome.
Okay,
Matt, is that your?
Shorten the string. Shorten the string. Shorten the string.
Zach,
What?
I didn't lick my finger. Zach,
Oh, you stepped in it.
did I rip? Okay, so now we're going to shorten the string, is that cool?
You have calves. You have calves on
Go really
your
fast this time.
So, what do you guys think is going to, what do you think is going to happen if we shorten the string?
It
It'll
won't
swing
be.
faster.
No, yeah, it won't be like as big of wavelength.
It's
Go,
gonna
Matt,
be
thanks.
it's gonna be like long. It's like longer.
If it's shortened?
Yeah.
Okay.
Shorter. Not longer.
Do you know what we call that, of how like tall it is? That's what we're talking about, right?
Oh.
Amplitude, right?
Yeah, I just
Okay, so you can,
You pulling again?
This bag is a little messy on the
oh,
outside right
that's-
here, so. I wanna get
so
it
make sure you're in the middle. And you're still up at the same height, cause it's gotta be up. Yep, good.
Oh, you should shorten it more. Like it's gotta be like touching.
Okay, so shorten it more. Shorten it more.
Be like touching it.
And now go up higher.
I'm keeping it the same.
Okay, this is good. Okay,
Yes, it's gonna end bad.
okay, you guys gotta go at the same speed,
Go like
okay?
go to the front of the paper too, like at
Put.
What?
she's not at that front of the paper.
Oh, okay.
Ew, it's so drippy.
Look at the stream, it looks cool.
That's not gonna go.
I know, I kind of
You moved it!
You hit my leg.
What kind
That's
of graphic is
okay.
this?
That looks good. It does. Miss Rita, look, it looks like a lady.
Okay, to be honest, I actually did move it, but then you hit my leg, and
Oh.
I'm like, oh, whatever, it's gonna. I'm just gonna
What are you talking about, looks like?
Okay, we
She
can
got
look
it,
at
man,
over
of a
that
hall.
right there, maybe this time.
It's hair.
Yeah, look
Okay,
at
come
it.
come over.
High five. She got from him. High five again.
How does it look like a lady? I mean,
Okay,
Look
um,
at the face.
what I want you to do with the next
And it's
7
hair.
minutes. Listen. Thanks. I want you to draw like a standard type curve. So that would be like the first one that we did on your notebook paper. And then I want your teams to make changes to it. So change the amplitude, change the frequency, change all of those things. And once your team decides we want it to have lower amplitude, then I want you to sketch that graph just so that you get used to sketching different sine curves, okay? So choose what kind you want to draw and then sketch them in your teams. Ready?
Set.
Go.
Yeah, come
So we
from
got
like
some
kill out.
constructive
Okay,
criticism for next time.
Yeah.
Gloves.
We can go, yes.
I'm gonna go wash my hands real quick.
Take the, wherever, I'm just gonna get
Alright, if I go.
Yeah.
I'm so confused on what goes away.
So draw like a standard type curve, and then you and Maddie say, okay, well, what would the curve look like if she moved really slow, and then sketch that one underneath it. Just a couple. Good. I should have had him hold the, when he was trying to shorter, it should have been closer to the paper.
You know, people call me the Da Vinci in my home.
Right? This is second the table wasn't very full of fire. So I think
No, this is big. We'll put a scale factor on this, it'll look huge.
like we'll say like each one's a mile.
I'll put a key, like, it equals 1 mile. Like, yeah, and it equals 1 mile.
And
And is that, yeah.
yeah.
We're
That's
supposed to
what
do,
the shape would look like if the paper underneath the pen on fell this fast.
we did that.
No,
Why don't we
it would
get
be
smaller?
like stretched out. Why is it going straight down? Yeah. I'll straight out.
This is what it'll look like.
Yeah, if we twisted it, like,
That'd be dope.
that's what I want. Yeah.
You ever taken drawing too? Or
Yeah.
drawing one?
I've never taken art in high school or middle
That
school.
one looks like a volcano.
Brian, you should take drawing.
Shut up, Jay.
Just because you are doesn't.
I have a B minus.
Yeah. That's because you're
I've taken art since 6th grade.
She gives you homework that you have to spend an hour on to draw stupid like Mrs.
Are you
Blue.
working with your team?
It's
Yeah.
so stupid.
Are you lying?
No.
Yeah, he is.
Liar.
Can we spin it now? And twist the string?
Why? That's gonna make a mess.
Awesome.
It would make a mess.
Just put like all three like right next to each other. And put it
Eventually,
in
the
the
first thing
center.
to pass, everybody in here would be covered.
And put it in the center of
Let's
like
have
the
a
middle
big
one.
one, please.
Like you see what I'm saying?
Yes, I do.
Katie, right? Is blue with food coloring?
Put it in the middle.
Yeah.
And water.
This way you have it right here.
What?
It actually looks like now that she said it.
Speaking of stuff doesn't look very easy at all.
You have to like. Are you mad?
Huh?
Are you mad?
No, I'm over it.
18 days to prom.
Nice. So what happened here? This one? Yeah.
Okay, you got it?
I got it correct.
Karen.
Is that 7-2?
Karen will take
That's
it.
7.
Yes. What about this one?
Three's homework.
Yeah.
Yes.
Okay, what about,
Well, I think my first homework round done.
Everyone's moving really slow.
Was it team design your
right, so that's more or.
We have one on that
Well, I
side.
mean, this could just be that too, right?
That one over there, we
This
have
one is kind of complicated.
Single, tackle Adam. You want this binder clip, Mr. Eagle?
Huh?
You want this binder clip?
Whatever we did.
Yeah, I'm
there.
gonna use that whole thing again,
Well, that's regular.
so it needs to be
I'll
back.
take the.
I want to hear her play.
Nice catch.
Eric Miller. Yep.
Nice draw some sketch. Oh, nice. Nice. Nice.
standard.
What's this?
No, I don't know why you want to say what it is.
Yeah, good.
There's a comma, semicolon.
Is that how we're supposed to do,
So
Mr.
what
Phil?
happens, what?
Is that how we're supposed to do?
Yep,
Do you
you're
have all
good.
12?
What happened with this one, Robin? What would be the situation for this one? Okay. Yeah, that would be one thing, because it's taller, right? And I would say that this might be
Yeah, she was going to.
slower, because there's a lot more of them.
If it was slower though, wouldn't it be farther stretching out?
Think about it,
That's
if
why it
you're,
says Margaret.
If it was faster, it would be this close.
It depends on how fast this thing is moving.
tell me why that isn't
What do you
true,
put?
If it was faster. Oh, if it was faster, it'd be more straight up.
right? Because it's,
Slower.
why though?
Because by the way it's moving, and then you're like.
So if you're going slower, it's gonna be able to fit more cycles in.
I'm not wearing
Spot on paper, right?
Right.
How could I make it so that it's got less amplitude? Like, so it's taller.
I wanna know who's doctor or nurse walking down the hall. Like,
Okay,
you're
you
very
have to
not,
hit
you're not very
labels
focused.
a little bit more on the
Miss
normal.
Dempsey was telling me that it was like,
If you want it, like,
Miss Dempsey was telling me.
Yeah. Did you believe that? Alex,
I was running, gotta go catch it.
I was there too.
I will ask for show amounts of stories from my house.
alright.
Good job. You don't have to be working where I work.
Is that what it says?
Did it?
It says, show Karen how to make her graph.
Nice.
Literally, you're not gonna get a job. No, man, we're hiring.
What?
Yeah. The difference, sine, cosine, or sine curves go through the origin and cosine curves don't.
They'll agree. Oh,
Okay.
once you you would actually.
Hey, good job today, guys. Thank you for your help.
Thank you.
How many money?
Yeah.
I'll pay you to do this. You can have my paycheck. It's just make it easier.
What makes headline?
I'm never gonna stop trying, Brian.
I know who will care for it.
What? Yeah.